completing them, I started bio.
Acha. So what is a redox reaction in terms of oxygen? If we will see, removal of oxygen is a reduction. Okay. Removal of oxygen is reduction. So when oxygen is removed, the substance will be reduced. And addition of oxygen is oxidation. Addition of oxygen is oxidation. So how we can see this thing in this chemical reaction? Before the reaction, it was lead oxide, and after the reaction, it has become lead. It means oxygen is removed. Oxygen is removed. So this is reduction. This is reduction. And you can see before the reaction, it is carbon, and after the reaction, it is carbon dioxide. Oxygen is added to carbon. So that will be oxidation. That will be oxidation. So you can see reduction and oxidation are taking place, both of them in one chemical reaction. So that's why we are calling it a redox reaction.
This only works
But
for oxygen, right?
it is only in terms of oxygen. Will you copy this thing or shall I rub the board?
No, you rub it. I did it last time.
Acha. Now in terms of electron transfer, if oxygen is not there, then in terms of electron transfer, how we are going to see, for example, zinc is reacting with sulfuric acid, H2SO4. So zinc sulfate and hydrogen gas will form. Plus hydrogen, H2. So first of all, we have to convert this equation into ionic equation. What does it mean? You have to write down the charges on each and every particle over here. So zinc means single atom of zinc, 0 charge. Hydrogen plus 1, sulfate minus 2. Zinc plus 2, sulfate minus 2. And hydrogen molecule is a covalent compound, so 0 charge. Now here we will see that before the reaction it is zinc, 0 charge. After the reaction it is zinc with a plus 2 charge. Before the reaction it was hydrogen with a plus 1 charge. And after the reaction it is hydrogen with a 0 charge. So some changes are taking place in between zinc and hydrogen. But what about sulfate? Before the reaction, it was sulfate with a negative 2 charge, and it was sulfate with a negative 2 charge even after the reaction. So sulfate ions are the spectator ions. What is the meaning? The meaning of the spectator ions means they do not change. They are unchanged in terms of their charges before and after the reaction. So they are spectator ions. So what we will do now? We will remove the spectator ions. We will remove the spectator ions and we will make our equation simplified. How you are going to make your equation simplified? See, Zn with a 0 charge plus 2H positive ion, arrow, Zn with a plus 2 charge and H2 with 0 charge. So now if you will see before the reaction, it is zinc with a 0 charge and after it has become zinc plus 2 charge. So when a positive charge appears, it means loss of electron is taking place. So what is loss of electron? Oxidation is the loss of electrons, OILE. And reduction is the gain of electrons, RIGE. So zinc 0 to zinc plus 2, loss of electron is taking place, oxidation is taking place. And H positive to H0, the electrons were lost before the reaction. But after the reaction, the charge is 0. It means the electron deficiency is gone. How? By the gain of electron. So this is called reduction. This is called reduction. So oxidation and reduction are taking place in the same chemical equation. Got it?
Yes.
And we did some experiments in the previous class. Iron nail is dipped in copper sulfate solution and copper wire is dipped in silver nitrate solution. So the color change and all those things I have explained to you in the previous class. You just have to read.
Yes, yes.
Okay. Once again, let's revise what is a displacement reaction. What is a displacement reaction? A displacement reaction is something related with reactivity series. Something related with reactivity series. What is reactivity series? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, and then copper. So those who are below hydrogen in the reactivity series, those who are below hydrogen in the reactivity series, they are totally unreactive. Totally unreactive. And you are moving down, the reactivity is decreasing. You are moving down, the reactivity is decreasing, and above hydrogen, the reactivity is increasing. So, for example, if I react magnesium with copper sulfate, so you see these two metals. These two metals. Magnesium is at a higher position. Copper is at a lower position. So, this highly reactive metal can easily push away the less reactive metal and form magnesium sulfate, and copper will be separated. Copper will be separated. But if I react, let's say if I react lead with aluminium chloride, for example, if I react lead with aluminium chloride, so see lead is at the lower position. It is less reactive and aluminium is highly reactive. So a less reactive element cannot displace a highly reactive element. So the reaction will not happen. So we have to remember the reactivity series, as I told you before, PO, CAM, ALZIL, HICOM. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. So you have to remember this reactivity series. Now, another thing, just let me close this. I will show you something. Just give me 1 minute. Okay, so now let's see this thing. You can take a screenshot if you want
Okay.
of this thing, which I'm showing you. Reaction of metals with air, water, and acids. Okay, so this is the table. You take the screenshot of this table. So now we will see. Now we will see that group 1 metals, those who are in group number 1, those who are in group number 1, like potassium and sodium, even in group number 2 also, potassium, sodium, calcium, specifically about group 1, potassium and sodium, they explode when they come in contact with oxygen in the air. They explode. And when they explode, they burn with colorful flame and turn into white ashes, forming their oxide. The white ashes are their oxide. So when sodium will react with oxygen, it will form sodium oxide. When potassium will react with oxygen, it bursts into flames and form potassium oxide. When lithium will react with oxygen, it bursts into flames and form lithium oxide. So same is the case of calcium and magnesium. They are in group number 2. So the reactivity is little bit decreased. So they also burn in colorful flames, but you have to heat them, not as explosive and automatic reaction like potassium and sodium. Rest all of them up to lead. Up to lead. They are transition metals. And below hydrogen, the reactivity is zero. No reaction, no reaction, no reaction. So aluminium, zinc, iron, lead, you have to heat them strongly. From here till here, you have to heat them strongly in the flame. They become red hot and slowly they form their oxide. The color will change. Copper, silver, gold. Below hydrogen, do not react at all. Do not react at all. Okay. Now, reaction with water. Similarly, the same way, group number 1 elements are explosively reactive in water. So potassium and sodium, if you put a small piece of sodium and potassium in water, they burst into flames. And what they're going to form? Alkaline solution. So what is the alkaline solution? Let me show you here. When sodium or potassium will react with water, let me show it here. For example, sodium will react with water. It will burst into flames and it will form sodium hydroxide and hydrogen gas. There will be a fizz of hydrogen gas. So this is the case of group number 1. Group number 2, very slowly they react with water. Very slowly they react with water. I mean, group number 2, this up to calciums. What is group number 2? Group number 2 is beryllium, magnesium, calcium, barium, strontium. So the reactivity increases downward. They become more and more reactive when you move down. So beryllium and magnesium are less reactive. The rest of them are fairly reactive with water. So calcium reacts with water and it forms calcium hydroxide. It forms calcium hydroxide and hydrogen gas. But magnesium onward till lead, magnesium till lead, none of them will react with water. Rather, they react with steam. They react with steam. So when they react with steam, like magnesium reacts with steam is also water, but in the gas state. So I will write a small g over here. Solid. These are the state symbols. So in that case, it is not going to form an alkaline solution the way calcium and group 1 elements are forming. Rather, it will form solid oxide, magnesium oxide plus hydrogen gas. Just the color of magnesium will change. The color of magnesium will change. Magnesium is gray in color. When you will pass steam over it, it turns into white color. What does it mean? Magnesium oxide is formed. Magnesium oxide is formed. Similarly, aluminium, zinc, iron, lead, you have to heat them strongly and you have to pass steam over them. They will form their oxide and hydrogen gas. What is their oxide? They will just change the color. They're not going to form an alkaline solution. Whereas copper, silver, gold, whatever the elements after hydrogen, they do not react at all. Now, reaction with acids. So group number 1, as usual, violently react with acid and rest all the elements up to lead. They react with acid, but the reaction gradually becomes slow to slower to slowest. But in any way, when a metal react with acid, any metal when it will react with acid, it will form salt and hydrogen gas. It will form salt and hydrogen gas. Did you understand this idea? So you
Yes.
will see the class recording and you will I would advise you that you will I will give you the PDF of the notes and I will advise you at the same time to see this table thoroughly. Okay, now come to our books page number 146. You have to read these things from the book thoroughly. You have to read these things from the book. You have to read page number 146. The
I will
first
check.
chemical reaction, 146, the first chemical reaction which is given to your magnesium and copper oxide. So magnesium is more reactive than copper. So magnesium will displace copper. Magnesium will displace copper. And as a result, the reaction is happening with lots of sparks. You can see figure number 14.3. Why lots of sparks? Because this is an exothermic reaction. Similarly, some other chemical reactions are given on this page. Then on page number 147, redox reactions are given. On page number 148 and on page number 149,
Okay.
oxidizing and reducing agent. I will explain you what oxidizing and reducing agents are. Then on page number 149, see figure number 14.7. Reaction between copper and silver nitrate solution. A copper wire is dipped in silver nitrate solution. The reaction is happening. Page number 150. Page number 150. Reaction of metals with water. So group 1 elements, the summary, the table which I have showed you right now. Group number 1 elements explosively react. Group number 2 slowly react. And transition elements react with steam, but they do not form an alkaline solution. Acha, page number 141, there are two experiments. I will show it to you. Page number 152 and 153 also, there are some experiments I will show. Page number 154, a general summary. What is this general summary? This general summary is the table I showed you. That is the general summary. You have to read it. You have to read that. Page number 156. Page number 156, rusting of iron, I'll show you. So let's start with oxidizing and reducing agents first.
Okay.
So what are oxidizing and reducing agents? So it is something related with redox reaction. Agent is someone which facilitates something, which cause something to happen. So what do you mean by oxidizing agent? What is an oxidizing agent? Naturally, it causes something, so it will cause oxidation of something, oxidation of something. And what is reducing agent? What is reducing agent? It causes reduction of something, oxidation of something and reduction of something.
Okay.
Oxidizing agent cause oxidation of something, reducing agent cause the reduction of something. How? Let's see in terms of oxygen first. In terms of oxygen. In terms of oxygen. So let's see, for example, lead oxide with carbon. Lead and carbon dioxide will form. So from lead oxide to lead, from carbon to carbon dioxide. So you can see that in the course of the chemical reaction, lead oxide is reduced to lead. Removal of oxygen is taking place. Who is being reduced? Lead oxide is reduced. So reduction is taking place over here. Why reduction is taking place? Because carbon is here to take away, to snatch the oxygen and form carbon dioxide. What is the cause of the reduction of lead oxide? What is the cause of the reduction of lead oxide? Carbon. If carbon will not be there, lead oxide will not be reduced. So who is the reducing agent? Carbon is the reducing agent. So remember one thing, the substance which is reduced, its neighbor is the reducing agent because it is happening because of its neighbor. Similarly, carbon is oxidized to carbon dioxide. Why? Because lead oxide is here to provide oxygen to carbon. Otherwise, carbon would never ever be able to oxidize. So Who is oxidized? Where oxidation is taking place? In carbon. Oxidation is taking place in carbon. Who is the cause? Lead oxide. Why? Because lead oxide is here to supply oxygen to carbon. So who is the oxidizing agent? Lead oxide. So remember, the substance which is oxidized is neighbor is the oxidizing agent. The substance which is reduced is neighbor is the reducing agent. Did you understand this thing, Hiba?
Yes.
Acha, so how we are going to define? We are not going to learn the definition. We will first write the equation and then we will make our own definition. Like I can see over here, lead oxide is an oxidizing agent. So what it is doing, it is giving oxygen to carbon. So we can say that oxidizing agent supplies oxygen. It gives oxygen to something to be oxidized, supplies oxygen. And what the reducing agent is doing? Snatching away the oxygen. So reducing agent, what does it do? Removes oxygen. It removes oxygen. Did you understand this?
Yes.
Oxidizing agent supplies oxygen, reducing agent removes oxygen. Shall I rub the board?
1 second. Okay, you can raise.
Now, in terms of electrons, we will see what happens in terms of electrons. In terms of electrons. Again, I'm writing the same equation, zinc plus H2SO4, ZnSO4 plus H2. Then I'm writing the charges like 0, plus 1, minus 2, plus 2, minus 2, 0. Then I will remove the spectator ions and it will become zinc plus 2H positive. Zinc plus 2 plus H2, 0. Now you see, from zinc to zinc plus 2, loss of electron is taking place. So oxidation is taking place over here. For what reason? Because H positive ions are here. So oxidation is taking place. So the neighbor is the oxidizing agent. H positive ions to H0, gain of electron is taking place. Reduction is taking place. Why? Because zinc is there to do that. So the substance which is reduced, its neighbor is the reducing agent. So what reducing agent is doing? There was a deficiency of electrons in hydrogen. That's why there was a positive charge over here. It had already lost the electrons. So what zinc has done the favor? Zinc has supplied electron to hydrogen ion so that it can turn into hydrogen. So what a reducing agent is doing? Reducing agent supplies electrons. Reducing agent supplies electrons. And what an oxidizing agent is doing? It is snatching the electrons. So oxidizing agent removes the electrons. Snatching, we will not write, we will write removes the electrons so that it can be reduced. Removes the electrons. Did you understand this?
Yes.
Tell me when you finish writing.
Yes, just a minute. Yes, done.
Done? Okay.
Yeah.
Acha. Now see, we have done oxidizing and reducing agent. Now, page number 151. Page number 151. Okay. We have got 8 minutes left. Let's see how much we can finish in 8 minutes. So on page number 151, there is a small experiment like we have just seen that in the reactivity series, magnesium onwards, whatever the elements are there, they do not react with water, rather they react with steam because their reactivity is reactivity, decreases and becomes slow and slower and slowest. So there is the experiment you can see over here, magnesium, and there is a magnesium ribbon in a glass tube, and I'm going to show you this experiment to you. Just give me 1 minute. When you will see the experiment, then only you can understand. Sometimes the question, comes from this experiment in the O level. Okay, now see, I'm showing you the experiment. Understand the experiment, what is happening, and then we will discuss.
This is a demonstration of the reaction between magnesium powder and steam. It is a reaction that has relevance at GCSE in terms of the reactivity series of metals, and also at A level when looking at the properties of group 2 elements. Magnesium powder reacts slowly with cold water and a little quicker with...
Can't see the screen yet?
Yeah, but I can hear the audio. No, I can see now.
You can see now, na? Acha, okay. Now let's start.
It is a reaction that has relevance at GCSE in terms of the reactivity series of metals, and also at A level when looking at the properties of group 2 elements. Magnesium powder reacts slowly with cold water and a little quicker with warm water or hot water. But to see the reaction effectively, steam needs to be passed over some heated magnesium. A boiling tube is used. The steam is created by soaking the glass wool that is seen at the bottom there in water and then placed at the end of the tube. The glass wool is placed at the end of the tube. Of course, not cotton wool, because of course we're going to heat the tube. And then the tube is inverted while we soak the water, soak the cotton wool with some of the water. It is best to have the glass wool completely soaked with water, but with no spare water which can run onto the magnesium. That seems to be about the right amount. There doesn't seem to be any residual water present. If I then place some of the magnesium into the tube, I'll place it roughly halfway along, perhaps a little bit more. This magnesium is in the form of magnesium powder, which has a high surface area and therefore should interact quite nicely. There is the magnesium. I'll place the delivery tube back onto the boiling tube and we'll heat this combination. So first of all, I'm going to heat the magnesium. Some of the magnesium might start to spark a little as it reacts with oxygen in the air. But I will continue to heat until I see some of that sparking. And then as soon as I feel that the magnesium is hot enough, I will move the Bunsen down to the other end and start to vaporize some of the water. As I vaporize the water, a chemical reaction occurs. There it goes. And to show that the product is hydrogen that is being formed, I can light it at that end. And as I increase the production of the steam that's passing over the magnesium, you can see that I can make the flame of the burning hydrogen either a little bigger or a little bit smaller. Where the hydrogen is burning, you can also see some of the steam being condensed there into water because it's obviously cooler along here. And again, I can make the flame a little bit larger. So here is the hydrogen gas which is burning, and here the magnesium is being converted.
Okay, Hiba. So this is the experiment. From here, like we have got a very short time left, 1 minute. We will start our class from here tomorrow, but before that, you will see the entire video before tomorrow. Before tomorrow, you will see the entire class recording, this experiment, and we will start right from here, and we are going to finish this chapter tomorrow, inshallah.
Okay.
Understand, Hiba?
Yes.
So we will try to take, like, for big chapter 2 days, 2 classes, and for a small chapter 1 class, so that we can quickly finish our syllabus. So that's all. You study at home. I'm sending you the recording in some time along with the PDF of the notes. All right,
Okay.
Hiba? Okay, bye. Allah Hafiz.